So one of the things you have to do pretty frequently in a calculus course where you're not necessarily having access to the calculator all the time is use the unit circle to do trig calculations. One of the biggest issues I notice students having with that is flat out locating the angle. How do I figure out where this radian angle measure, right? We've learned degrees since we were young. We learn radians at some point in high school, and then we start using them quite a bit. I see difficulty in locating those radian angles. This is going to be the easiest way to try to locate those angles. So what you see here is you see a unit circle, which is a circle centered at 0, 0 with a radius of 1 unit. We want to try to figure out how to plot different radian angles on the circle. This is the only thing, other than a little simple arithmetic, this is the only thing you need to know in order to make this process successful for you. So pi radians is equal to 180 degrees. If you know this, plotting radian angle measures on the unit circle should be very easy. Let's show how. So on this screen, I want to take some time to plot the angle pi over 2. This angle is measured in radians. Now this one you've probably dealt with often enough that this one you might know, but here's how the process works. Go to that relationship from the last screen. Pi is equal to 180 degrees. This is an equation. I can keep it balanced as long as I do the same operation on both sides of the equation. And in this case, I see that pi is being divided by 2, so I want to divide both sides of this equation by 2. 180 divided by 2 is something that's easy enough to do. That's going to give you a 90-degree angle. So I already have the initial side of my angle plotted. That'll be the positive x-axis. And if I'm plotting a positive angle, I'm going to open upward through the first quadrant. Well, 90 degrees would mean I'm going through this location right here. So my terminal side for this angle would end up looking something like that. So pi over 2, we've now plotted that in standard position on the unit circle. Negative pi over 3. Now this angle is negative, so when we plot this, what we're going to do is we're going to work downward through the fourth quadrant, right? The positive x-axis is always the initial side of your angle. The terminal side, when you're plotting a negative angle, you're going to drop through the fourth quadrant initially. So I need to plot the angle negative pi over 3. Same exact strategy. Pi is equal to 180 degrees. I can keep this equation balanced by dividing both sides by 3. 180 divided by 3 is going to give you an answer of 60. So if I go 60 degrees through the fourth quadrant here, it'll put me somewhere a little bit more than halfway through the fourth quadrant, somewhere in here. And so the terminal side of this angle is going to end up looking something like that. So there's my negative pi over 3 radian angle plotted in standard position on the unit circle. Now to 5 pi over 6. Now this one's got a little bit more going on. I'm going to go with the same strategy. So ignore the 5 and the 6 that you see on both sides of this equation. It started with the pi equals 180. What I think is easier to do, there's two operations that need to happen, multiplication and division. What I think is way easier, make the number smaller first, then make it bigger again with the multiplication. So if you divide 180 by 6, divide pi by 6, 180 divided by 6 is 30 degrees. So I have to go a 30-degree increment 5 times around the circle's outer edge, and I need to do this for a positive angle. So if I start on the positive x-axis, if I go 1, 2, 3 30-degree increments, I'm here. If I go a fourth and a fifth 30-degree increment, it puts me to right here. And the terminal side of this standard position angle should look something like that. Now, can you recognize that 30 times 5 is 150 and plot that angle? Yeah, but if you just use this number as the number of times you're moving this increment around the circle, it takes off some silly arithmetic mistakes that you might potentially make. So I have a couple more here to do. 9 pi over 4, same strategy, right? So I'm taking pi equals 180. I'm doing the division of both sides first, so divide by 4, since that's my denominator here. 180 divided by 4 is 45 degrees. Now 45 degrees times 9, I can try to work that out and try to get some big angle and try to plot that angle. I wouldn't recommend it. This is a 45-degree angle. I need to go 9 45-degree increments around the circle's outer edge in the positive direction. So if I go 1, 2, 3, 4, 5, 6, 7, 8, looks like a ninth 45-degree increment is going to put me exactly halfway through my first quadrant, so a little bit past 360. There is that angle. Last one. So now we want to plot negative 13 pi over 6. So I have a negative angle, so I know I'm going to drop through the fourth quadrant initially when I try to plot this. Same strategy as we've been suggesting. Pi is equal to 180 degrees. Do the division first. Find your base angle. Well, pi over 6, right? The denominator back here is a 6. Pi over 6, 180 divided by 6 is going to be a base angle of 30 degrees. I need to go a 30-degree increment 13 times around the circle's outer edge, and I need to do this in the negative direction. So if I go 1, 2, 3 30-degree increments, 4, 5, 6, 7, 8, 9, 10, 11, 12, a 13th 30-degree increment is going to put me 30 degrees into the fourth quadrant, so not quite halfway through the fourth quadrant. We've located that angle. Now, you haven't had any discussion about how to actually do your sine, your cosine calculations within this video. Got another video for that. This video, we just wanted to talk about the easiest way to locate angles. If you've been having trouble with this from time to time, hopefully this strategy makes sense and will allow you to have success in doing it.